All right. Hi there. I'm Ward Bell. I'm president of a company called IdeaBlade. We make people happy writing software for them. And I also make Breeze.js, which is a library for data management, and I work on NGRX stuff too, because John and I John Papa will be talking later, worked on a library called NGRX Data, soon to be renamed, to make it easier to work with NGRX. So I've been hanging around a little bit. How many here know anything about Angular? Am I in the right room? Okay. Because this is an advanced talk, I'll bet you all use DI, dependency injection. I don't have to explain what that is. All right, let's see if I can't come up with some things you don't know. We're going to play, during the course of this, something called Find the Child Components and then talk to them. And we're going to make it harder than the way you might think. We're going to start off with some things you might know. This is the app, which there's actually an app that goes with this talk. And it looks like this. And it's got a bunch of things that can speak and a rock that can't. And if you click, I find them and they say something. And it would, what does the fox say? You may get that. So that's the app I'm talking about. And so there's some animals, and basically it's some kind of an animal container, and it shows these things, and you might have, that's where it does something. And you can imagine you write an app animals container tag component, and you just want to throw things in there, cats, dogs, whatever. The rocks shouldn't be able to talk, but everything else should be able to talk. And some of the items in there could repeat. All right, so you're the manufacturer of the app animals, right? And you want to say, hey, folks out there, give me components, write your own, just drop them in here, and I'll make them talk when the user does something. That's kind of the game. Try and imagine that you are the author of app animals, and you want to be able to tell people that they can put their own components in. So naturally, each component is different. Some of them might implement some animal interface. Some of them might extend an animal class. Some of them, the raw component doesn't do anything. Maybe the Viking, who knows what it does. So you can see those two implement it at the interface. This one extends it. Here, I want to stop for a second and talk about DI and classes and interfaces. Not everybody knows that you don't have to extend. You can treat a class as an interface, right? You can use it with extends as a base class, but you can just use it as an interface like you would any other, and that means you don't have to burn your base class. So here's my animal abstract class, because I don't want it to be able to be implemented directly. And I can just use this class where I would normally use an interface. So this is really important when you think about providing, because what happens when you try and use an interface as a provider? The answer is it doesn't work, right? And you know why it doesn't work? Because interfaces leave no trace in the JavaScript. But a class, and even an abstract class, does. And so, this is how we like to provide it. But I can use that I can use the class as an interface, so it's a great provider token as well as acting as an interface. So I do that a lot. So the Viking component, I have all these different things that can speak. Actually, it implements the animal interface, but I didn't even say it did. All right, so these are the kinds of crazy things that people might want to put in the animal container. Now, rock is just like nothing. Okay, so our mission is to find the animals, animal components, child components, and make them speak. And it's like, what do I do? What do I do? Well, let's think about the ways we could do it. It's going to involve content children, right? That's the way you look for things the animal component's going to look for things inside. So one of the things we could try is like looking directly for the Fox component. And after we do that, we set up the content children, and we go find it. We find all the instances of it, and then we tell them to speak. And this only works for foxes. I had to know it was a fox that was going to be between the containers, right? Do I actually know, as the author of the container, what each of the types is going to be? I do not. So I mean, even if you could tell me all the types, it would be crazy to kind of write all these content children for each of the different component types. That would be kind of crazy, right? Don't want to do that. Basically, the container, our implementation, shouldn't know anything about the types. All right? So trying to write a content children that looks for a particular component isn't going to be an answer to the question. Well, another approach is that each of these components that are dropped in there could, instead of the container looking down at them, they could look up and find the container. And then they could talk to them, right? In other words, instead of me, the outside guy, looking in and finding the content children, I'll just say, hey, look, if you're in there, you should find me. So this is like, how would that work? You have to know a little bit about injector hierarchies to see how the child could find anything up the tree. And it is a tree, because when you start this thing, there are actually, your mental model, it's not literally true, but your mental model should be that there's a hierarchy of injectors that comes down. So it starts from the platform injector at the very top, and then you have an application root, and then it's something like this. And then you have your app module, and your app component. Finally, we get to animal container, and then we have the individual components. All right, so you can imagine that there are just chained of injectors going all the way up. So if something's looking for something in cat, it can't find it, looks in animal container, not there, app component, app module, it works up. Mental model. It's not literal, but that's your mental model of the way this works. By the way, you do have to be worried about something called shadowing. So if I have a location service up there, an HTTP there, but notice how module has a provider for foo, an app component has a provider for foo, an animal container component has a provider for foo. And if any of these bottom guys ask for foo, what are they going to get? Which foo are they going to get? Exactly. Let's see if this thing works. Look at that. Ooh, that one. Oh, that is so cool. I just don't know how to do it. All right. So the first thing you want to register in your thought is that every component, when it's instantiated, registers its own, Angular registers its instance of itself, that component, with the CatComponent's injector. Again, mental model, not literal, but that's the way it works. And so without our doing anything, the animal container component was registered in its injector. And so if any one of these look for animal container component, it doesn't matter whether there are animal container components anywhere else, it's going to find the one that they're nested in, and therefore it'll get it. So, like Fox, which implements animal, can say, hey, I'm going to just use constructor injection here. Give me the nearest animal container. I'll register myself with the animal container. All right? Then the animal container will know who I am. I've announced myself. And then it can tell me to speak. You with me? All right? That works great. Then the animal container holds all the references to all of the little other components that have said, hey, register me, register me. This is, by the way, the way tab containers and tabs work. The tabs sort of know that they go find their parent tab container. They say, here I am, and now the tab container can manage the tabs. And see, it asks them to speak. The problem here is that you've got really some tight coupling, because when I asked you to go make these child components that could be dropped in there, I didn't really assume that you were going to make them only work with my animal container. Maybe they want to be useful in some other containers, right? Are they going to register with anything that could possibly contain them? That's not a really great design. So let's try something different. I don't know why it says view children, because I'm really talking about content children. So anyway, let's do that. What if the animal container could say, let me find the content children by animal? What would that look like? That looks like nothing. Can't find them. Even the ones that implement, even the one, we have one of ours implements as a base extended directly from the animal abstract class. Still can't find it. You cannot use DI to find something. By the way, content children uses DI. You can't use it to find something by its base component. You can use it to find it by component, by class name, but you can't do it by looking for its base. So In other DI systems, we can often find things by a base class. Can't do it here. So that's out. I'm showing you all the things that aren't going to work. Things that are not, that's mostly what this talk is. Like, that didn't work. That didn't work. When's he going to show us something that works? I don't know. All right, well, this might work. We can mark them all ones in there. We can say, well, when you put them in there, just put an attribute on it. So I'll make up an empty attribute directive that it's called an attribute directive because the way in which we'll apply it is as an attribute. It doesn't have to do anything, but its selector is animal. And now I could just go put animal on all of the ones that go in there. And I can just say, look, this is the convention. If you want to use something as an animal, put animal on it, stuff it in the container, and let's see what happens. That didn't work. It kind of worked. It found the animal directives. But a directive, we already saw it was an empty directive. I made it up. Doesn't do anything. Doesn't give us access to anything. Doesn't give us the component it's attached to. That's not too helpful. Well, let's try something else. Let's mark it with a ref variable. You've seen those things with a hash on them? All right. Let's see how that works. Hey, that works. See, I go at content children. Let's see if I can make this thing work. There. That's how you can find it by the name, the ref. And I could have just pointed at the screen, but it's so much more fun to use the gadget. And yeah, that works. All right, I could get the components that way, and because I could get the components that way, I could tell them to speak. I did miss the dog, though, because they didn't put somebody forgot to put the ref on there. And the Viking, and somebody put it on the rock, but it's not an animal. So this is fragile. That's what I think, anyway. You can say, at least I got something going, talk over, thank you, I'm out of here. But there's got to be a better way or a different way, anyway. So let's see. I don't know if you guys ever remember reading through code or anything like that, the source code or something and samples, and you saw this read parameter on the content children. Ever seen that thing? Wondered what it was? I know I did. I even looked at the source code back in the day. Couldn't figure out what it did. It wasn't documented at the time. Recently, they've been really working on the documentation. There is one very obscure clue in there. And that's new, but I can assure you, you can go click that link later when you look at the slide, and you'll see that it's not very helpful documentation. So I didn't know what to do with it, but I did learn eventually. So let's say we go back to our directives, right? That we marked with directives that time before. And this time we're still not finding it. Sorry, I'm refreshing your memory. That we couldn't get anything. We got the directives, but that wasn't really what we wanted. We want the components that the directive is attached to. But when we use the read, and we say read element ref, which is the only way I'd ever seen it, ta-da! We got element refs. That isn't the component, but at least I can read something other than the directive. I've got the element that the animal components are attached to. That's good. I can use that to do all kinds of manipulation. And in fact, a lot of attribute directives you'll see that get put on elements, that's what they do. They do it to manipulate the element that the directive is attached to. They do it to manipulate the element that the attribute is attached to. So in this example, I'll put this little black border around the element because the directive helped me find those. And you notice the rock is missing because I didn't have it on there. So a couple of fun facts. As I mentioned, each component instance has its own injector, mental model. That read thing that we just used to get the element ref actually gets a value from the injector, which tells you that, by the way, somehow when Angular instantiates a component, it puts that element ref in the injector, very conveniently. And the component instance is in there somewhere. So, and number 3 is what we're going to leverage. So this works. If I go animal directive read FoxComponent, if, all right, the thing that has an animal directive on it is associated with the FoxComponent, I can get it. which was, I could have done it just by going FoxComponent from the beginning, so I didn't make any ground here. But there's what I'm getting across here, that the fact that these two are the same thing, is the little difference is that read parameter is getting it in a different way. It's actually reaching into the injector of the directive to get it. So, but we still have the same problems. This is only good for foxes and stuff like that. So it's not a solution, but it's on the road to a solution. You learn something new about content child and about how this read thing works and the fact that it reaches into an injector. You learn something new. And we're going to use that thought in the next part, because there's another provider trick called use existing. Now, everybody knows about putting the class in when you just make a list of providers, you just put the class there. Under the hood, you know that what that translates to is provide, use the class as the token, with using the class as the thing that creates the service. You can also, you know about provide, use class, right? Everybody knows that. And we know use value. But how many of you have ever used use existing? Anybody in the room ever used use existing? See, you are going to learn something. Ever use that? That says, I'm going to give you a token called my alias, and I want you to associate that token with another thing in the injector that you know about, another existing thing. And that other thing has some service as its token. All right? Now, if I were to inject my alias into it, what I get is an instance of whatever the some service is a token for. Let's say it again. My alias is a token. It's an alias for a substitute for another token, an existing token, in this case called some service. And so what it allows me to do is go find that other service known by that token of some service and get it. Now there's a thing to be aware of. Because use existing, use class, what's the difference? Are they interchangeable? And the answer is no. If you were to use class instead, my alias would not point to whatever some service is. It would create another instance of some service. Now I've got two some services in my injector tree. That's not what I want. What I want to do is use existing. I want to make sure that I don't create a new instance of some service. I want to refer to an existing instance of some service in the injector. Pause. Let's chew on it. That's the difference between use class and use existing. Okay. So we're going to use that thought. All right. We're going to use the alias to go make the things that we don't know anything about available as animals. So I'm going to take that Fox component, for example, and I'm going to say, you know what? Yes, I've got Fox component, but what I want you to do is I want you to announce to the world that there's an alias for what I am. And the alias for what I am is animal. I am an animal. All right? That's what it's telling the world. Doesn't know what an animal is necessarily, it just says I am one. Anybody wants to know? Well, this one happens to implement animal, but it wouldn't even have to. Remember, the Viking didn't implement anything, but it could announce to the world that it's available as an animal. And I do that to each of the other components that's out there. Now, basically what I'm saying is if you want to play ball with an animal component, animal container, or actually any container that you want that wants to play ball, play the same game, just pick this token. It could be an empty token called animal, and say whatever I am, cat component, dog component, Viking component, fox component, I'm just saying animal is a alias for what I am. Animal is an alias for what I am. Now, it turns out there's animal. If you really dig down into the injector that's underneath the cat component, you dig down in there, you'll find that it has an animal. Because we did this provide use existing thing. I'm in there. I'm in there both as cat component, which is right below animal 67, All right, I'm in there as my own class, but I'm also in there under the alias animal. So now, instead of reading element ref, or instead of reading FoxComponent, I read animal in my because now I don't, anybody who uses animal as an alias is now going to show up. And I've got it. You see in the debugger that after I go and get those content children, by looking for the alias, I get the components. And as soon as I've got the components, I've got them in my array, and I can tell them all to speak. With me? Well, then I thought that was like the bomb. That's the whole story. When I got then I said, oh, but there's a new surprise. Because something changed somewhere along the line, and it got better. Because the alias trick I need, but it turns out I don't need that directive. And that directive was a pain, right? I had to go create this empty directive and put it on things. And it's like, what is that for? Didn't need it. Like, this is what I want to write, isn't it? I just want to throw them in there. That's my ideal. That's nirvana. That's me sitting there, in warrior tree pose, whatever the heck that is. So it turns out that any of those are projected in, the content children are projected into the container component. It turns out that any of them that has this alias, any of them that uses this animal interface, now that we've set it up this way, can be found directly. Content children, animal. There they are. The secret is that you put this aliasing on any component that wants to participate in the game. And then I can go get them. So that's a reminder that I've used up my 20 minutes, but that's okay, because we're getting close to the end and I'm going to take questions. So let me say that again. So here's what it takes to play this game. All right? You know that some container out there is going to you consume things, go find things with the help of an interface, which, by the way, is an abstract class, because remember I told you at the beginning, use abstract classes as interface tokens because it makes life easier. So I do that, and then any component that wants to ever play in this game, the game at the top, simply implements that using the aliasing, like I talked about. Does that. And now I got it. And that is how you can find content children whose names you don't know, but that are willing to announce themselves as providing an alias for themselves that is something that others can consume. And that's all the time I have. So that's your advanced DI talk.